Just like we use decimal notation in our math class, inside today's computers, information is encoded as patterns of zeros and ones. These digits are called bits, short for binary digits. Although you may be inclined to associate bits with numeric values, they can actually represent many things, depending on the application at hand. Patterns of bits are used to represent images, sound, alphabet, and even symbols. Now, let's compare between decimal notation and binary so we can get a clear view. Decimal notation is also known as a base 10 system because we only use 10 digits to represent it, from 0 to 9. Let's take 375 for example. It can be represented as 3 times 100 plus 7 times 10 plus 5 times 1, or for more technical notation, 3 times 10 power 2 plus 7 times 10 power 1 plus 5 times 10 power 0. On the other hand, binary notation is also known as a base 2 system because we only use 2 digits to represent it, zeros and ones. Whenever you want to figure out the binary representation of a decimal number, I want you to always map this table on your paper. 2 power 0 equals 1 is going to be the least significant bit, and 2 power 7 equals 128 is going to be the most significant bit. That's only in our case because I'll be using only 8 bits to represent my number. Let's say I want to represent the number 37. All you'll need to do is fill the table above with the values that, when summed, is equal to 37. How? Well, let's follow a simple algorithm. Step 1. Check your table and make sure there are no values bigger than 37. So in our case, we cross out the 128 and 64, leaving the most significant bit to be 32. Step 2. Check your table and see what numbers when added would give 37. In our case, 32 plus 4 plus 1 equals 37. Step 3. We fill the table with ones in the 32, 4, and 1 places. You know, the ones that add up to 37. And the ones that we didn't use, the empty spaces, we're gonna fill with zeros. So we're left with 1, 0, 0, 1, 0, 1. And voila! But, you know, we only used 6 bits to represent 37, and I want to use 8. So, we're gonna add zeros on the left side, in the 64 and 128 place. Since I didn't use them, remember I crossed them out. Now, let's take a bigger number, for example, 112. I'll give you a moment to pause the video and try to figure it out by yourself. How do we tackle a big number? First, as we've established earlier, we'll put zeros in the places we won't be using. 128 in our case, since it's bigger than 112. Then, we're gonna take 112, subtract from it 64, and it's gonna equal 48. Then, we're gonna take this 48, subtract from it the 32, and we're gonna get 16. Bear with me here, we're almost done. Then we're gonna take 16, subtract from it 16, we're gonna get 0. And that's it, we're done. We're gonna put ones in the 64, 32, and 16 places. Now let's check if we're correct. 64 plus 32 plus 16 equals 112. So we are correct. We did it. We're done. Of course, binary, as we mentioned above, is represented in a wide range of things. In this video, we only covered how to represent positive integers. In future videos, however, we'll see how to perform algorithmic operations using binary notation and how to represent negative and decimal values. Check the description box for the worksheet you have today as homework, with detailed answers attached to it. Feel free to ask anything you're confused with in the comments. Subscribe and see you next time.
Created using Powtoon.